Hello, greetings to you all from my side. Like I had told you in the introduction video of this playlist that I will be covering certain subjects from the electronics science syllabus for the UGC NET exam. So here I am starting with the electronic devices and circuits, and as we all know that basically in the UGC NET examination in-depth knowledge or in-depth conceptual questions are mostly not observed. So what I'll be including in this playlist is the key formulae of the EDC subject. That is a quick revision, a very quick recap of the essential formulae that will help you to solve the questions easily and quicker. So the first thing that I will be including in this series of video or this playlist is the mobility of charge carriers. I hope all of you are well aware of what exactly mobility means, but just giving you a brief about it is that mobility of charge carriers basically means that how fast the charge or the charge carrier is traveling from one place to another, denoted by mu. Mu can be calculated in two different ways. First is a very general, most common formula Vd upon E, that is drift velocity per unit electric field. Why do we use this formula is because drift velocity we know is proportional to electric field, hence mu here is the constant of proportionality, that is also Vd can be equal to mu into E. So mobility of charge carriers is drift velocity by electric field, Vd upon E. Another thing is in case of just electrons, you can use this particular formula, that is mu equals to E tau upon m. Here E obviously is 1.6 into 10 to the power minus 19 coulombs. Tau is the mean free time of the charge carrier. M is the mass of electron, that is 9.1 into 10 to the power minus 31 kg. This is mostly used for electrons. So mu is equal to E tau upon m is the second way to calculate mobility of electrons. Mostly this I have searched over the net, and mostly the calculations that we do, we use this particular value for mu e and mu h if it is not already mentioned in the question. In case of electrons, mu e is 3800 centimeter square per volt second for germanium, and for silicon it is 1300 centimeter square per volt second. So this will be the formula based on that Vd upon E formula. This will be the unit, sorry. So in case of germanium, for holes the mobility will be mu h, that is 1800 centimeter square per volt second, and for silicon it will be 500 centimeter square per volt second. So these are mostly these come out handy in case it is not mentioned in the question already. You can just memorize these values and use them directly. Also a key point to remember is always mu e is greater than mu h, that is the mobility of electrons is greater than that of the holes. Even for the same amount of electric field, electrons move faster than the holes, hence their mobility is greater than those of the holes. Also, another key point is mu, that is mobility of any charge carrier decreases with increase in the temperature, that is mu is proportional to T to the power minus m, or you can say that mu is equal to 1 upon or proportional to 1 upon T to the power m, where m is mostly a constant. For holes, m in case of the germanium it is 2.33, for silicon it is 2.7, whereas for electrons you use m equal to 1.6 is for germanium and 2.5 for silicon. So again these values come out handy in case of you need to use them directly in any formula in any question. So this was just a basic recap of the mobility of charge carriers from the EDC point of view, from the EDC subject. Next I will be including the conductivity part, and I hope so far this very brief is clear to you. Still, in case of any query, do drop your comment. Thank you.